continue what we left in the previous class, electric currents and its effects. So we did discuss so many things, and at the last moments I did told you about different symbols of different electric components also, right now. So the functioning of the electric bell, if you guys have any confusion in it, feel free to ask me. Okay, now I am here, I will be able, if possible, if you want, I can re-explain that also. Yeah,
Sir,
Chakrika,
can
how
you
are you?
please explain it?
Yeah, sure. Okay, Chakrika, you want me to explain this again? Electric bell, did you got this or not?
I got it, sir. You can explain it again.
Okay, okay, let Viga and Tessin also join. Let wait for 1 or 2 minutes. Okay, now while you guys can answer a few questions to me. Okay. All right now. Also, both of you tell me what is the full form of MCB? Yeah.
Sir, can I say?
Yeah, Chakrika.
Sir, it's called miniature circuit breaker.
Miniature circuit breaker. Sundar, you tell me, we use it in place of what?
Electric fuse.
Electric fuse. Very good. Also, there are different type of electric fuses. Yeah. Nowadays, you would see that even if you were to have a simple extension board, you guys understand an extension board? There also, you will see there's a
Yes,
fuse
sir.
here. It looks like this. Like this, you would see. So fuses are also of different types now. Okay, now. Also, do tell me, like both of you, why CFLs are preferred over the electric bulbs? Starting from Sundas. Why CFLs? Okay, now. Why CFLs are preferred over electric bulbs? While Chakrika, you would answer to me what is the full form of CFL?
Okay, sir. So, who should answer first?
First, Sundas, starting from you. Why CFLs are preferred over the electric bulbs?
Sir, because I think they use less energy.
Exactly. Also, Chakrika, I will come to you also. But first, one more thing needs to be discussed. Like talking about an electric fuse now. You can't, like nowadays, there are fuses installed in devices also. Just like I gave you an example of a wire extension. Okay, no? Wire extension board. So there also you are having a fuse. In fact, in televisions also there's a fuse. All right, now. So earlier what we were doing now, from the main power supply, okay, now there we were installing a fuse, right? Right now, today also we install a MCB there, miniature circuit breaker. But nowadays, what we are doing, we are installing fuses in certain devices also, right now. So that even if this MCB somehow fails to stop the flow of excessive current, so that my my expensive devices does not uh, get damaged, right? So for example, if I were to use a electric motor, a motor that draws water from the underground, that motor I'm talking about. All right. Or for example, if I were to use let's say an extension board here. So in those two things, will I be using the same type of fuse wire? Will I be using the same type of fuse? Did you guys got my question?
I didn't get the question.
Look, simple question is that I have an electric motor using which I am taking out water from the ground. Okay. And on the another hand, I have an wire extension board. Okay, now let's just simply say that I am having any device. Uh, let's take an example. Which example you guys can take? Let's take any other example, or just take the example of wire extension board. Right now, I'm not remembering any other. So take another example of wire extension board. So in these two devices, will you be using the same type of fuse? Yeah, will same type of fuse will be used. First of all, you guys need to understand, like, is the energy requirement of a wire extension board or an electric motor same? Answer this simple thing to me first. Or just take an example of this electric bell, let's say. Okay, now we can take example of an electric bell also. Let's say we have taken an electric bell and we have taken electric motor. Okay, the electric motor that you are using to draw water from the ground, that motor I'm talking about, and you have an electric bell. So the question is that will you be using the same type of fuse in these two devices? Yeah, just answer to me like whether it's yes or no. Yeah,
I think no. No.
no. Chakrika, what about you?
So I still didn't really get it.
You still did not got the question.
No, sir.
Okay, okay, look here. Say that no. Uh, let's say I am having two devices. For example, I am having a device that consumes lots of energy. For example, an electric heater. Huh?
Yeah, okay, sir.
So let's say there's an electric heater of 2000 watt, right? And let's say I have any other device, for example, an electric bulb, electric, not bulb, electric bell, and that has the energy requirement of, let's say, 100 watt, for example. So will you be using the same type of fuse in the two? Will you be using the same type of fuse?
So maybe not.
So because the reason is now both of you look here, because the reason is that in an electric heater and in an electric bell, the energy requirements are different. The different amount of currents are required. This will draw more amount of current. This will draw less amount of current. Hence, due to that, we will be using different type of fuse now. Got this question or not? Yes.
Yes.
Okay. Moving on, I did ask one question to Chakrika. That was what was the full form of CFL? CFL stands for
So compact
Hmm,
fluorescent lamps.
compact fluorescent lamps. Very good. Okay.
Lamps.
I did also told about full LED also. Sundar, so you remember the full form of LED? If you guys have
The
been
what?
noting the things down, what is the full form of LED? LED.
Light. Something
Mhm.
like
That the
I
first
don't
word
know.
obviously will be
Sir,
light.
I don't think we discussed the
I
full
think it
form.
is emitting, right? The second from
Second
me.
one is emitting. I think
And
we discussed that. Sundar, continue.
I
No,
think
sir,
we
I
did
didn't
not
think we
discuss
discussed
that,
it.
sir. Or
We didn't
like,
discuss that, no?
yes.
Oh, okay, okay. Actually, we now discussed about incandescent bulbs, the CFLs, and then I think about that too only we discussed. No? So do remember that uh, LED, which you normally hear of, nowadays it is used because it is more energy efficient. That stands for light emitting diode. Okay, no? So this is just this is the only thing important about it. Another thing is that it is a more energy efficient. Okay, no? So light emitting diode is also there. Okay, okay. Let's continue from here. Working of an electric bell, as Sundus asked, let's understand about its mechanism again. How does it basically function? So you know that in order to ring the bell, first of all, what do we have to do? You'd be required to push the switch. We will be pressing the switch button in order to ring the bell. So when we press the switch now the what happens? The electric circuit is completed. Whenever we press the switch of anything, if the wire is not broken, then electric circuit is completed. That is the thing everyone knows, right? No. Okay, give me one more thing. Let me take a fresh page, or let me. I will have to erase this now. Just give me 1 minute.
I mean, sir, can you just give a minute?
Yeah.
Just a minute.
Okay.
I just need a minute.
Okay. Okay. No issue. Okay. While Chakrika can tell me, who was the person who discovered magnetic effect of electric current? Yeah, Chakrika. Who was the
Uh,
person who discovered magnetic effect of electric current?
Come back.
sir,
Yes, on this.
Orsted?
Orsted, Hans
Orsted.
Orsted.
Hans,
Very
or
good.
Hans Christian Orsted.
Very good. Very good. That was the person, right? Okay. Also, does Earth also behave as a magnet? Hmm.
Yes, sir.
Yes.
It does.
Exactly. Exactly. So let's understand the mechanism of this electric pulse. So basically, what is happening here now? When you will be pressing this switch, so thereby circuit is completed. So now when circuit is completed, so at that time, what is happening? Happening now, current starts flowing in the electromagnet. So when the current will start to flow via this electromagnet, then it will generate magnetic field, right? So look over here, like this magnetic field be generated. Magnetic field is generated. So magnetic field is generated. So thereby what will happen? Now the hammer will be attracted towards it, right? It will be attracted. So see here, this electromagnet will now be attracting the soft iron armature. So thereby, while it attracts the soft iron armature towards itself, so thereby this hammer will hit it now, right? Now, once it does that now, see, this is an iron screw. Okay, so once it does that, once it hits the gong, now it separates from this iron screw. Suppose, yeah, see, say this is an iron screw. All right, now look at where I'm pointing. Is it visible or not? Uh, Say this is an iron screw and this is an soft iron armature. Okay, now. So once the circuit is completed, this will move away from the contact of this iron screw and then it will hit the gong. It will hit the bell right now. So once it has detached from the contact of this iron screw, now the contact is broken, hence circuit is broken here. Getting it? Let me repeat that again. What happens when this electromagnet generates magnetic field? So thereby, this soft iron armature is attracted towards the magnetic field. So thereby, it will hit this gong. While doing so, the contact from this iron screw of the soft iron armature breaks now. So due to that, circuit is broken here. So circuit is broken here. Also, one more thing needs to be noted here, that since the circuit is broken, so this will no longer produce a magnetic field. So since this is no longer producing a magnetic field, will the soft iron armature still get will it still be attracted towards this gong? Yes, Sundus. Yeah, Chakrika. Hello.
Yes, sir.
Will it still be getting attracted?
No.
Mm-hmm. No. Why? Because when it got detached from the iron screw, at that moment, what happened? The circuit was broken. So since circuit is broken, so no longer the current was flowing in the electromagnet. So since current is not flowing at that moment in this electromagnet, so magnetic field is not produced. Hence, it will this iron armature will no longer be getting attracted towards the gong. Hence, it will fall back. It will move away. It will move back, and then again it will be connected to the iron screw. It will again come into contact with it. So then now again circuit is completed, and again the whole process will repeat itself. I hope you got it, or not. Yeah.
It's on
Yes, sir.
spring.
Yes, on this.
From spring, I didn't get it.
From the spring you didn't get it. Okay. How about now I show this animation again? I hope that will make you understand it once again. See, just look over here. I think it is from here it will
Introduction.
start.
Of
See from here. Just you have to look at the iron strip and look at the contact screw. Pay attention there. Okay, and the thing about the spring is that because if there is no spring there, so then what will happen now?
strikes
The
the
iron strip
gong
will
of the
break now.
bell.
So that the iron strip does not break, so thereby there is a spring over here. Right now, see this over here
To
again.
produce sound. Summary.
You can notice that the circuit is
Let us
continuously getting
summarize what we have learned.
connected and broken. All right now.
Yes.
Okay. So now it's time to take some questions. By the way, these questions I have not taken from the anxiety, because in anxiety you have got very simple questions, and I believe you guys can do it yourself. So I have taken questions from anxiety exemplar. Okay. If you guys still have some question from anxiety textbook, you guys can ask to me anytime. Okay, no issue in that. So starting from question number 6. Which property of a conducting wire is utilized in making electric fuse? Sundus, you answer this to me. Second one, Chakrika. So like this,
Okay,
you
sir.
guys will be answering. First Sundus, then Chakrika, then Sundus, then Chakrika. Okay, but for in question number 8, there also first Sundus, then Chakrika, like that. Yeah. Also, I would pause you guys for 1 minute. Do tell me, like in the whole chapter, is there any point which you guys haven't got? If there's any question, any doubt, please
Sir,
do
can
let
I
me know.
just go through like 1 second
Okay, through the whole chapter, like what we basically did in the chapter now.
until what I've noted down in like the notebook and notes.
Okay, sure. Okay, now.
Okay, sir.
So basically, we started the chapter, and then we now first of all we did discussed about this thing. What are charges? We did discuss that charges are basically positive and negative charges, and these are developed due to unequal amount of protons and electrons in an atom. We discussed that if there is
Yes.
extra electron in an atom, so thereby it develops negative charge. If there is deficiency of an electron, it will develop positive charge. So that was the concept we discussed. And then we saw that there are two type of materials, conductors and insulators. One which will be allowing the flow of current, one which will restrict the flow of current. Right now, those will be called as conductors and insulators. Right now.
Sir.
Mhm.
Um, in the question, yes, sir. I'm done going through everything, and in the questions,
Okay.
the first question you also asked yesterday, sir, but I didn't know the answer.
The first question, this one,
Yes, sir. In the questions.
question number 6.
Yes, sir. You asked it yesterday also.
Okay, I think we discussed that question yesterday also.
Only
Okay.
that question you
Only
asked
that
us
question.
yesterday, sir.
Okay. So now I think you should be able to understand it now. Like which property of a conducting wire is utilized in making electric fuse? The simplest thing is that while we are making an electric
Sir,
fuse now. Yes.
sir, is it like if the thinner the wire, then the greater amount of heat will be passing through the fuse? I mean, like through the.
That is also the thing. Also, main factor which we take care of here is that the wire should be having a low melting point. Okay, now.
Yes, sir, like
Also, you could know, for example, normally the copper wires. In our houses, we have the circuit of copper wires. The circuit consists of copper wires, and there are several bundles of copper wire. Right now, they are like 5 or 6 copper wires which are twisted in a bundle. Right now, it's like that. It's like that. They all are twisted like this, and then enclosed via an insulation. So the thing is that if you were to take just one copper wire out of it, okay, now you can use it to make a fuse, right? Now, so the point that uh, the thickness should be less, that is also correct. But the main point we need to take care of here, that electric fuse should be having a very low melting point. It should be having low melting point. Why? Because if I were to use a thicker wire now, like this, then what will happen? It will be having a higher melting point. But if I were to just use one strand of copper wire, then it will be having a lower melting point. Okay, now, did you got it or not?
Yes, sir, I got it.
Okay. So we did discuss about charges, about conductors, insulators, right now, and the heat produced in the wire. Talking about how heat is produced. Heat is produced because of the resistance offered to the flow of electron in a given wire. Huh? Whenever current will be flowing in a wire, and if electrons are getting some obstruction in the flow, so thereby heat will be produced, and heat will depend upon several factors like what is the material of the wire, what is the length of the wire, and what is the thickness of the wire, right? Then we saw that, yeah.
So what was the first question? The sixth question?
Sixth question was that which property of the conducting wire was used in making electric fuse?
Okay,
That
sir.
was the
So,
question.
For the second.
so
Yes, on this.
I'm very sorry to ask you again, but can I have like 2 minutes?
Okay, okay, no issue, no issue. But be back, but come back quickly. Okay. Hmm. Yeah, Chakrika. Any other questions?
Oh, no, sir.
Okay. Also, uh, when we talk about conductor and insulators, you know that our body is also a good conductor of electricity, right? Now? Okay.
And so
Then
silver is the best conductor of electricity,
exactly,
right?
exactly. Silver is the best conductor of electricity, but we can't be using it. We can't replace it with. We can't replace the
With
copper wires
wires.
with. Exactly, because it is very expensive
Yes, sir.
right now. So that is the thing. When then we saw like these are the factors that will determine the amount of heat produced. These are very important. Do remember that. Okay. Then we saw based on the
Yes, sir.
heating effect of electric current, there are several appliances which we are using right now. Okay, these were some of the examples of it. Huh? So, for example, in an electric iron, we would be using nichrome wire, right? In the incandescent bulbs like this, we were using tungsten to make the filament of it, right? Now, okay. Also, sometimes students confuse like these are the just supporting wires. These are supporting wires. This is the only material that is made up of tungsten. Okay, no?
Sir,
Mhm.
sir, in CFLs, that part is called something, right? Like, the supporters.
In the electrodes, we call them as electrodes.
Electrodes. Oh, okay, sir.
Electrodes. Okay, now.
Okay, sir.
And then we did talked about electric fuse also, right? We discussed about its mechanism. Yeah? Now I did told you like this type of fuses are used in the electrical appliances. You might have seen it. Huh?
Yes, sir.
You might have seen such electrical fuses. I am having one right here also. If you want, I can show that to you. But the power connection will be disabled. Okay, now. So that is the thing. And
Okay,
then
sir.
we did moved on to talk about like this, how excessive current can pass through a circuit. How can excessive current pass? It will be either due to short circuit, either due to overloading. Right now, we did talked about how the bulbs have evolved over the course of time. Right. So we did discuss that. We did discuss a little bit about the functioning of CFLs also. Right now. So where basically what was happening now, mercury vapors were coming out of this structure, right? And then in the inner lining of the sepals, there's a phosphor coating of phosphor, right? And then that was helping to reflect the heat into the surrounding. So like that, it is functioning. Okay.
Yes, sir.
Then we did talked about Indian Standards Institute also. What is the ISI mark?
Yes, sir.
So basically, it's like a standard mark which says that the certain product is now safe for use. So whenever you buy electrical appliances and the cookers, make sure there's a ISI mark written on it. Okay, now because even you say like cooker, what would be the danger in it? Cookers are kind of dangerous thing if not handled properly, or if someone is using a cooker of local company. There have been several cases where it explodes. We talked about MCB also. That is a miniature circuit breaker. It is nowadays used in place of fuse. So that will automatically turn off, right?
Yes, sir.
Now,
Sir, and
yeah,
continue.
yeah, and we did talked about the electric components. What are the symbols of the electric component? So you guys can practice it yourself. Okay. We did talked about magnetic effect of electric current also, right? So in high classes, you will understand like what happens, that there is some distortion in arrangement of electrons. So due to that, magnetic effect is created. Huh? I will not go into details of that because you guys won't be able to grasp it right now at the moment. Okay, no. In higher classes, you will understand like how exactly magnetic field is being created due to the flow of electric current. So also I did told you like the direction and the amount of deflection of this magnetic needle compass will depend on the direction of flow of current and the strength of the current. Yeah, Sundus, are you back or not? Yes.
Yes, I'm back.
Okay. So we did discuss that as well in the class. And then we studied about electromagnets and electromagnetism also, right? So electromagnets are artificial magnets, and we can turn a piece of iron into an magnet by passing currents through it. But in order to make an electromagnet, you would be surrounding coils of wire around the given piece of iron. Also, in high classes, you will be studying about solenoids also. But let's not go there. You will be having trouble then. And then we did talked about electromagnetism. So electromagnetism basically the process of passing electric current via via a piece of iron to make it electromagnet, and then thereby magnetic effect is created. So all this whole process is called as electromagnetism. Then we did talked about applications of electromagnet magnets. These are used in different type of appliances. For example, these are used in toys. It is used in electric bells. Right now, there are different uses of it. Okay, and right now we are having some questions. Okay, so we have pretty up
Yes.
summarized it. All right now. Also, do note that overloading and short circuit happens. There is a slight difference between the two. There's a slight difference between overloading and short circuit. In short circuit, what was happening basically, when you would be connecting too many electrical appliances in a single socket, so they will be drawing an extremely large amount of current from the circuit. So due to the flow of large current, overloading will lead to generation of heat, right? And thereby the wire will be heated and very high temperature will be generated and it might cause fire. So that is simply overloading. While short circuiting, what happens when electric current is supplied in the household through two wires and which are running parallel to each other like this. In our house, two wires are coming from the main power supply. These are running parallel to each other like this. So if sometime what happens, there's a cut in the wire. There's a cut in the wire, or if the two wires were to come in contact with each other and there's a cut in the wire. So now what will happen? They will come into contact with each other right now. So there are two wires. There's live wire and there is another insulated wire is called as neutral wire. So when the live wire and the neutral wire comes in contact with each other, so now current starts passing through the only one of the wire. It's like this. There's this wire, there's this wire, somewhere they joins, and now current will start to pass through one of the wire. So due to that also what will happen? High amount of heat will be generated. Hence that will also lead to short circuit. That is simply short circuit. Okay, now. So basically what was happening now? Look at the term short circuit. You know about circuit. What is circuit? What is a short circuit here now? So the question is that earlier, this was the circuit, let's say. Let's say this is a bulb here. And via these two wires, the current was passing. Right now, and let's say this is a circuit. And there would be
So,
some power source here. Yeah, Chakrika?
sir, to write the definition of short circuit, can we write that it happens in the system where a neutral and the live wire comes in contact with each other?
Exactly. You can write that. Right
Okay,
now.
sir.
So when these two wires comes in contact with each other, now the current starts flowing through only one of the wires. So in due to that, what happens? Large amount of heat is generated. Right now, so that may cause fire. Also, if you were to understand why it is called a short circuit, because earlier the circuit consisted of two wires, but if the two wires were to come in contact, let's say each other, they were to come in contact here. So now what has happened? Now the length of the circuit has shortened. It has become shorter. So that's why it is also called a short circuit. Hope you guys are able to relate with this. Okay, no? And then we did study the functioning of electric bell also. Right? So I have just given you a overview of what are the things we discuss in the chapter. Okay. Let's do the questions in whatever the remaining time we are having. So question number 6, Sundus. Moments ago we discussed that question. Okay, now that low, yes, low melting point.
Low melting point.
Exactly. Question number 7. Have a look at this question. Yeah.
Name the device used these days in place of electric fuses in electric circuits. Sir, it's MCB, miniature circuit breaker.
Exactly. That is MCB. Question number 8. Yeah, Sundus.
Our body is a conductor of electricity.
Good. Yeah. Chakrika.
An
Yes.
electric cell produces electricity from the dash in it. Sir, chemical reactions?
Exactly. So on the basically chemicals that are found in it. Right now, basically chemicals found in it. Okay, next question. Sundus. In an electric circuit, a fuse is a it's kind of a safety device. No? Exactly, safety device. Okay, next question. Chakrika.
Yes, sir. A combination of two or more cells is called a battery.
It's called a battery. Very good. Question number 9. We have to unscramble the following words here. First two, Sundus, you answer. Next two, Chakrika, you will answer.
Okay, sir.
See what is the answer for these 4 options. Yeah.
So, like, can you give me a minute to like unscramble it?
It's a simple thing, no? Like these are basically like this.
I was
That is
confusing this battery and fuse.
battery and
Fuse.
fuse. Very good. Yeah, you Chakrika. While Sundus, we look at question number 10.
Sir, I'm still figuring it out.
Okay. Like just think of what a different type of could it be a type of could it be an electrical component, could it be an electrical device. Either it will be a component of the circuit, or either it will be an electrical equipment. Okay, look, there is S in it. Huh? There is a W in it also.
No, sir. It's the third one, right?
No, third and fourth, both one you have to answer.
Yes, sir. So I'm figuring
Uh-huh.
what's the third one.
Okay. Try to figure it out quickly. So that is actually, if I see, it is actually a, yeah,
Sir, torch.
exactly. That is a torch. Okay, now. Question number 4.
Just a second, sir.
Mhm.
Sir, switch.
Switch, obviously. Good. Yeah, you start looking at question number 11 now. Now, Sundus, done. Question number
Okay,
10.
sir.
Yes, sir.
Hmm. The question
Well, sir,
says
should
that,
I say the answer?
you have to see the answer.
No, she has not taken the right step
Hmm. Why is it so?
because, like, the electric bulb wastes electric energy in the form of heat.
Right. Also, you know that here it says that Paheli does not have a night lamp in her room. She covered the bulb of her room with a towel in the night to get dim light. Right. So many times people do that. But also here in the question, it has not been specified like what type of bulb is that. But we are considering it to be a incandescent bulb, the glass bulb. So that produces heat also, right, Chakrika, Sundas? So that might also burn the towel. Okay, no. So hence that is not a good thing to do. Okay, now Sundas, you look at question number 12. Chakrika, done. It's a simple question,
Yes,
I think. Question number 11.
yes, sir.
Mhm.
Why are compact fluorescent lamps, CFLs, preferred over electric bulbs? So CFLs are preferred over electric bulbs because they save energy, sir.
Exactly.
Um, they consume like very less energy,
Hmm. Exactly.
and also they produce the same amount of light, but like less. They use less electricity.
They in fact produce more amount of light. Okay, no. In fact, they produce more amount of light, right?
Oh, okay, sir.
Uh, okay, okay.
Sir, and they have like longer lifespan than electric bulbs.
Exactly, exactly. Also, it will not be producing any amount of heat right now.
Yes, sir. Yes,
So
sir.
that
And
is the
also,
thing. Mhm.
it is also, so this is a fact that I heard.
Mhm.
Um, I heard that they are also like eco-friendly. Like
Eco-friendly.
like they produce less greenhouse gases.
We produce less greenhouse gases.
Yes,
Basically,
sir.
the thing is now, uh, because it is easy to dispose them because
Yes,
they
sir.
does not contain toxic materials in it.
Yes, sir.
So you have compact fluorescent lamps. LEDs are also the most friendly bulbs you will be having. Most environmental friendly bulb you will be having. Okay, now so that is
So
the
they're
thing because
also
they do
like
not release
less.
toxic materials. Yeah, they're also.
They're also less. Like they're not that expensive.
Exactly, exactly. They are
They're
not that
less
much
in cost.
expensive. Exactly. Also,
Yes.
if you were to look at CFLs and look at LEDs, if you were to do the comparison between an LED, remember that LED is the better version of the bulb. Huh? LED is superior than CFL bulbs. So, like if you were to have a 16.5 watt LED bulb, if you're having a 16.5 watt LED bulb, so that will be almost equivalent to the 20-watt CFL. Getting it now? Equivalent
Yes.
in what terms? The amount of light given by a 16 and
Yeah.
a half watt of LED bulb will be equal to the amount of light given by the CFL of
CFL.
20 watt.
Yes, sir.
right now. So one should be adopting LED bulb, but still somewhere you will find people who would be using incandescent bulb. Why? Because it is cheaper. It will cost only
Yes,
like
sir.
15 rupees, I think 15 to 20 rupees. But nowadays, LEDs are also, uh, it comes, I
Cheaper.
think, somewhere depend. Yeah, it is also cheaper. It is not that much expensive. Okay, moving on. Question
Can
number.
zoom out. Yes, sir.
Yeah, yeah.
Nothing, sir. I was asking
Okay.
you to. I was about to
Mhm.
ask you to zoom out.
Okay, okay. Huh. Question number 12. That was to you, Sundus. Question number 13, Chakrika.
Like to protect them from the excess current
Mm-hmm. Exactly.
flowing. Okay, sir.
Exactly. Exactly. That will restrict the excess flow of electric current by simply melting. It will simply melt. Hence, the circuit will be broken, right now. Hmm. Now, Sundus, you know, look at question number 14. Yeah, Chakrika, question number 13. In fact, we discussed such question moments ago. I have discussed that.
Yes, sir. Sir, I don't think so. We can use the same fuse in a geyser and television set,
Mhm.
and that's because sir, geysers they have like high power ratings compared to TVs.
Exactly.
They need more current when they are needed, like when we are using them.
Exactly.
So like if we use a fuse that is too small, it can like blow the fuse out. So or like it'll be overheated
Mm.
so that there can be a fire.
Exactly.
And then for a TV, like using a too large like fuse may not provide protection, like if there is a short circuit.
Hmm. 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 Okay.
So yes, sir.
Okay. So basically, the thing here is that a geyser typically requires somewhere around 1500 to 3000 watt. 3000. There are different type of geysers available in the market. Their power ratings are different. Some geyser a small geyser will be using 1500 watt. Okay, or bigger will be either using 3000, or there could be a 4000 watt as well. All right now. So now here high current is flowing here. Right now, since high current is flowing over here, that is the thing. While a typical TV will be using somewhere between to 15 to 300 watts of electricity. A typical, I'm talking about the typical TV. Okay. So I am seeing that different amounts of energy is required by these two type of devices. So obviously, since high amount of current is flowing over here now, and lesser amount of current is flowing away, so due to that, different type of fuses will be used here, right now. So that is the thing. The fuse you will be using for the geyser, you can't be using that same fuse for the television, right now. Why? Because I know that high amount of current will be flowing, so thereby I would be using uh, a fuse that will be having a high resistance. Okay, now, while you can't be using that for this TV as well. Okay, moving on to question number
Yes.
14. Yes, Suntas. And question number 15, Chakrika.
So like for the first one is like
Hmm,
geyser, and
good.
for the second it is like electric bulb. I mean electric bell. Electric bell.
Electric bell. You have to give two examples for each.
Uh geyser room heat I guess, and
Mhm. Cranes. Hmm. Cranes. In toys also, in several toys also, magnetic effect of current is used. Question number 15. Yeah,
So can I
Chakrika.
have 2 seconds?
Okay, take your time. Yeah, Sundus, you also read question number 16.
Oh yes, sir. I think I can answer it.
Yeah.
Okay, sir. Why do
Mhm.
we cover plug pin holes which are within the reach of children with sellotape or a plastic cover when not in use? So we do that for like various reasons. So one main important is like for the child safety, for their
Exactly.
safety, because children,
Hmm.
they're accidentally like, as they're kind of curious minded people,
Mhm.
like as their children, so
Exactly.
they insert the objects into the electric outlets.
Mhm.
So
So they,
that's why they cover with sellotape or plastic when not in use. And
Mhm.
also, it's also for the electrical safety, sir. Because if we insert any electrical, I mean, any objects into the electrical outlets, it
Mhm.
can lead to electrical shock or like any electrical dangers or something like that.
Exactly. That is the
Then,
reason why it is covered.
yes, sir. Also, it prevents damage, sir. Like,
Mhm.
if any, by mistakenly, if any liquids or any objects enter the sockets, that can
Mhm.
cause short circuits, and it can also damage the appliances, right?
Exactly.
So,
Exactly.
and it can lead to fire. So, that's why.
Exactly. Also nowadays, the electric socket boards that are coming, they are more safer. Huh? You would see like are electric socket boards where you will have to apply a little bit of pressure in order to insert the plug. Why? Because at the back of it, there's a cover. Huh?
Yes,
Uh,
sir. Like, I
there's a
have
kind
like
of cover.
three
Huh?
plugs which are like that, three
Exactly, and you
outlets.
will exactly, and you will have to apply a little of bit of pressure to insert the plug into the electric socket board. So that is
So,
uh, that has been made considering the safety measures. Yes, Sundar. Yeah, Chakrika.
so this might not be related to the lesson, but
Mm-hmm.
like the uh, pins, or like the charging pin.
Uh-huh.
Then we insert it in the adapter.
Yes.
Uh, s- when we insert it from another side in the adapter, it won't fit in. But when we turn it around and when we insert it, but it will fit. Why? So
Okay, so you are saying basically what I'm able to understand that you have a socket like this. Okay,
yes, sir.
and
Like it's an adapter which we use to plug in the
mhm.
socket.
There are three
Yes,
pins in it like this.
yes, sir, like that.
There are three pins in it like that.
And then
Right
like
now.
down there's like a pinhole, right, to insert the charger pin
Hmm.
wire, like the charger.
Okay. So basically,
So
mhm. Complete your
yes,
question.
sir. Yes, sir. So when we insert it on the other side, it won't go in, like it won't set in the hole.
Okay. So you see that
But like
they
when
are.
we
Mhm.
but like when we put it the other side and when we insert it in, it goes in. Like it perfectly fits into the hole.
Okay. So what I'm able to understand from your question that you get to see that there are different type of electrical boards, right? Now, one will be having pins in it, and then you will be having like that as well, like that. Yeah. So you'll be having such boards also. Okay. Now. So I think the simple answer to the question is that why it would be fitting in certain way, because I think because um when these boards or the adapters are made now, so it is basically kept in mind that it should be getting fit it into it now.
Like
Okay.
not for the
By
adapter,
the way,
sir,
the
like
other
for the charger, the
for the
wire
charger.
which we connect to the adapter.
Okay, that thing you are saying to me now. Okay,
Yes,
now I
sir.
got it. I thought like you were saying about how it gets okay, that thing now.
No,
Okay.
yes,
Huh,
sir.
basically the thing is now. Okay, basically if you were to look at it, see, uh, say this is an adapter, and this is where you insert the USB cable. So why it won't fit the other side? Because if you were to look closely at it, there's a plastic thing over here. See over here. I don't know if you guys would be able to see it. See this thing over here. Yeah. Can you guys see this thing in my hand? This is a USB cable. Can you guys see there's a white
Yes,
plastic in
sir.
it? You guys can
Yes,
see it
sir.
now? So basically the thing is now half of it consists of a white plastic. So it will be fitted into that part, but in that part it won't be fitting. Okay, now so it is basically so that it fits into that now. See that if this was also empty, if this were also to be empty, and this were also to be empty, will it fit into it? Obviously no. So for
No,
that
sir.
purpose it is there. Okay, now okay, coming back
Oh,
to the question. So in this question number 16, I think you were required to do that one. Yeah. Yes,
Sorry,
understand.
did you see?
Question number
Um,
16.
so for the first question, the answer is Paheli, Pahelis, and for the second one, um,
Hmm. You guys
I
remember one
don't know.
thing? You guys
sir,
remember
can
one
I try?
thing? Some Chakrika, you can try.
Yes, sir. Sir, I think um, Paheli's electromagnet will attract more pins
Mm-hmm.
because he double he 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 has like more turns over an iron screw,
Mm-hmm.
and that produces more heat. I mean, that produces more electricity.
Not electricity,
So that
magnetic
it,
field. Magnetic field. It
yes, sir.
produces.
So that it
Uh,
produces more magnetic field, which can have the ability to hold the more, which can hold the more pins.
mm-hmm. Okay, now, somewhat similar question Sundus also answered, but she just didn't explain it that much. Okay, now, okay, Chikrika, good. Both of you have answered it. So basically, the thing is that in the chapter I did told you, if in an electromagnet, if I were to increase the number of turns of the coil, huh, if I were to increase it, so thereby what will happen? The strength of magnetism will increase. So that is the thing. So Paheli's magnet as having 100 turns over the iron screw. So hence strength of magnetism is more. So thereby it will attract more pins. So that is a simple thing. Okay, now. Also, I did told you like how we can increase or decrease the strength of electromagnets, either by increasing the amount of current flowing in it or either by increasing the turns of coils. Okay, so far you guys have been doing good. So we have got few questions here also. Question number 17. Who would like to answer this one? I'm giving options to you guys. Question number 17. Okay, you guys are thinking too much. Chakrika, you have to solve this one, okay? You have to answer this one. And question number
So can you
18.
just like read the question once? What's the question?
Sure. Question number 17 says that no, your teacher
You
has
have to write down any three questions that comes to
write down
our
any three
principal.
questions that comes to your mind about this activity.
Okay, sir.
What questions comes to your mind? Also, Sandus, you have to answer question number 18. First, read the question carefully. Okay, I think we have left 5 minutes, so how about we do this together? Okay. So let's read the question. It says that first of all, understand this circuit given over here. Yeah.
Yes, sir.
In the circuit, I am having an iron screw. I have
Yes,
a
sir.
rounded wire over it,
Yes, sir.
and
A
I'm
coil
having this.
switch.
Okay, this is a closed or open switch, by the way.
Sir, it's an open circuit. I mean
What?
closed circuit.
Closed circuit, no? Because you have, if you are having a switch like this, so that means
Then
it
it's
is
an open circuit.
off. Switch is off. Basically, circuit is open circuit.
Yes,
Right
sir.
now, Sundus? And this means it is on. That is
On.
closed circuit.
Yes, sir.
Okay, and also here, which hand of the symbol denotes positive terminal, the longer arm or the smaller arm?
So the longer one denotes the positive, and then the smaller one denotes the negative.
Okay,
The
so
smaller notes the positive, right?
no, the smaller one
The
is the
long.
negative, the longer one is positive. Okay, now. Hmm. So let's understand the question. Teacher has wound a long insulated piece of wire around an iron nail in the form of a coil. Now, free ends of the wire are connected to a cell through a switch as shown in the figure. The current is switched on and some pins are placed near the ends of the nail. What questions comes to our mind now? Huh? Like,
Uh,
first of all, yeah, I think both of you answer this question. Okay, na? Both of you answer this question.
okay, sir.
Mhm. First question should come to our mind is why the iron why the pins get attracted to this iron nail? This question should come to our mind.
Yes, sir.
Yeah, Sundus, Chakrika. Come on, you guys also think of the some
Uh,
questions
so,
that should arise. Yeah.
so will it be able to hold many pins?
What if I were to increase the number of cells here? Huh?
So,
If I
sir,
were
can
to
that question be valid?
exactly that question be valid. Like what will happen if I were to connect more cells in the battery? Huh?
Okay,
Will it attract more pins? Huh,
more
Sundus,
pins.
Chakrika? Okay, no. Mm. Also, think of some other questions also now. Like what if mm, what will
Oh,
happen?
sir,
Yeah.
I have one question. So what if the coil, the wire of the coil
Hmm.
is thicker? What happens
Huh.
if the coil is thicker?
Exactly. We can think of that also. What if what basically this wire is more thicker? What will happen that in that case? What if you have not taken an iron nail, instead of that you have taken a piece of plastic? You have simply taken a
Yes, sir.
plastic straw. What will happen? Will then also will then also magnetic field be generated? The obvious answer
Then
is
also we can also frame a question like what happens if we use um wire which has low resistance?
which has no resistance. Basically, you won't be able to find such wire because every wire will be having some amount of resistance. Okay, now even if it's a wire made up of silver. Okay,
Like
now hmm.
um
Low resistance you said. No,
according
low.
to the
You said low resistance. I think
yes, sir.
low resistance. So if it is having low resistance, more current will flow through it, and hence more magnetism will be generated.
Yes, sir. So,
Uh,
so that question can also be applied, right?
yeah, that will also affect. Yeah, Sundus, you also think of some questions that should be arising in this activity. Hello.
Yes, sir.
Yeah, Sundus, what will happen if I were to increase the number of turns here? Huh? If
Or
you were,
increase the current.
hmm, yeah. So if I were to increase the number of turns of wire on this iron nail, so then also something will happen, right now. So these are some of the questions which we can think of, right? Now in question number 18 now, here there are two circuits given. Two circuits are given. Okay. And Paheli has took a wire of 10 centimeter here. And Bujo took a wire of 5 centimeter here. Okay, na? And these are of the same material having the same thickness. Both of them are same material and same thickness. And both of them are connected to the circuit here. Right now? These are two wires and these are now
Yes, sir.
connected to the circuit. They are having lengths as 5 and 10 centimeter. So the question is that the current flowing in both the circuits is the same. Current is also flowing. The magnitude of current flowing in the two circuits is also same. First question is that
Sir, have a
yeah.
Sir, in the question they mentioned thickness. So basically, the wires are thicker, right? Because they
Basically,
mentioned thickness.
it's mentioned that thickness. Thickness basically refers to the diameter of the wire.
So basically, they are thick. The
Obviously,
wires are thick.
basically, when we say about thickness, it does not necessarily imply that the wires are generally thicker. No, I have anything in my hand, it will be having some amount of thickness. By thickness, we basically refer to its width, or if it's a cylindrical object,
Basically,
then it
it's
will be
size,
having
right?
diameter, basically size,
Okay,
right?
sir.
And that thing we are saying. Okay, now, so when it says like the thickness, so it's basically referring to its size. It does not mean to say that it is thicker, not in that context. Getting it now? Okay, so first
Okay, sir.
question is that hope you guys have understood this circuit. What is basically
Yes,
happening
sir.
in the circuit? That is correct. O- Okay. So question number one: will the heat produced in both the cases be equal? Yeah.
Sir, I don't think so.
Sir, no.
No. Right now, because we did discuss in the beginning.
Because length also matters with
Exactly.
material size and magnitude of.
Exactly.
Yeah.
Exactly. And apart from length, everything is same here. The thickness is same, material is same, but length is differing. So no rights on this. And check it out. Question number second: with the will the heat produced by the be the same if the wires taken by them are of equal length but of different thickness?
No, sir.
Again, no, because if the thickness is more, then lesser amount of heat
Lesser
will be
current
generated.
will be. Yes, sir. I mean, lesser heat will be generated.
Right now. Okay, so that's it for today. Question number 19 and 20. Do that as part of homework, okay? As part of your assignment. Okay,
Sir,
make sure you
what
submit
are
that. Mhm.
chapter?
Yeah.
Like, what are we in next class? Which chapter are we gonna continue?
That was important thing to be discussed. In next class, I think we should be doing the forest hour